Very good morning, guys. Can you hear me? What about now, guys? Can you guys hear me now? Thank you, Ansul. Thanks, everyone. So, very good morning, everyone. How you guys are doing? I remember some of you might not be in our last class. I think Sarad was there, Arad was there in our last class. Not sure about Joseph and Vishnu and Nayan. We'll wait for 2 more minutes for other people. So, Sharad, or like whoever was in our last class, have they tried to solve any of the problem from assignments, or they have just solved the problem which we have discussed? Arad, Vishnu, Arad, Sharad, any one of you have tried to solve this assignment question? Okay, no problem. So I think, yeah, we have now the long weekend, like whole day of today and Sunday as well, then whole day in Monday as well. So definitely I will suggest you to practice those problems. First, complete all of the stack problems. Okay, like from where we have started, then we discuss next greater elements, then we discuss some of the applications of those problems, like the sub array minimums, maximum histogram area, and maximum rectangle in the binary matrix, right? Stock span. So please try to solve these problems and then move into the next chapter. Then try to practice the next chapter. Okay. So today what we'll do, we'll look into some of the assignment problems, and I will just give you conceptually or logic wise their ideas, and then we can move into today's class. I can see Vishal has also joined. So LFS, why not take one for 55? So Suraj is asking one question. So let's look into his question as well. 1 minute. Let me 1 minute. You guys are able to see my screen? Great. Okay, so let's see. Suraj's doubt. Why not take 1 for 55? Why not take 1 for 55? So why not take 1 for 55? Okay, so Suraj, if you're talking about the left side, lowest, smallest element at the left side, so the reason for not taking this 55 as a lower, because we in the duplicate scenario, in the duplicate scenarios, we can only consider 55 as a first, as a one time only element, because it's duplicated. So that's why when we are counting the right side slowest element, we have already added 55 as a smaller one. 55 as a consider is 55 as a smaller one, but in the left side we are not treating that 55 as a smaller one. So that's why we are reaching to the last of our, that's why we are reaching at the starting index, which was -1. Because in the duplicate scenario, whenever we are getting duplicate scenario, if you want to create a sub array of those duplicate elements, you will consider 55 only at the one time. In the duplicate scenarios, whenever we are getting a duplicate number, not getting. Okay, let me show you with example. 71 55, 82, 55. Right, guys? Let's create their subsets. Let's create their subsets. So 71, this one. And let's change the color also for 55 because these are the duplicate one, right? Okay, so let's take them now. 71, this is the first subset. This is a second subset. I think we can take it as a green. Now we have 82. Now we have the blue 155. Now let's combination of this. 71 is 71, 55. Then we have 71, 55, 82. Right? Then we have 71, 55, 82, 55. Correct? And now this 71 is done. Now let's move into these things. 55, 82, 55. Correct? Now let's see 55, 82. And this 55 is the green one, sorry. This 55 are the green one. Okay? So now I think 55 is also done. 55 is also done. So now let's take for this thing. 82, 55. And then the last 55. Correct? So that's what I was explaining you, that while counting it out the left side of it, so this 55 will be only one time. See, in this scenario, let's consider this scenario: 71, 55, 82, 55. What is the minimum? Which is 55, right? Which is a 55. So now you can see there are 255, but we are only taking 155. Correct? There is 255, but we are only taking 155 out of it. Same goes here also. In those 255, we are only going to take 155. So that's why when we are counting out right side greater or left side greater, we only have to consider that 55 one time. We only have to consider that 55 one time. So that's why when we are counting the right left element, right lowest element in that diagram, at that time I have counted it as a lowest. I have counted it as a lowest. That's why if you see, remember 0, 1, 2, 3, so you can see for 0, the right lowest would be 1. For 71, index would be 1. Correct? For 55, I taken this as a lowest one. I am considering this 55 as a lowest. I am considering this 55 as a lowest. So that time I am taking this as a 3. Next time for 82 is also 3, and for this this would be the next index, or 4. And when I'm counting it, sir, from the left side, it means I'm starting from this one. So I'm not counting this as the slowest one. I'm not counting this 55 as a lowest one. Correct? So that's why I am moving directly to the this part. That's why I'm reaching it here, because there is no minimum element for 55. I'm not counting this 55 as a minimum element, because these are the duplicate element. We can only consider them as a one element. That's why we are considering 55 as a one place as a lowest element. And then you can see in the left side element when I'm going. So for the 55, it would be -1. For 82, it's 55 only. For 82, it would be 1. For 55, again, no element. For 71, no element. So that's the reason. That's the reason for 51. For this 51, I'm considering also as a -1, and for this one also -1, because for this one makes sense, because there is no lowest element. I think you guys might be having confusion for this one, right, Suraj? So the reason for that is, first time already we have considered that as a one of the 55 as the smallest one. So in the left side, when I'm counting out, I'm not considering the other one as the smallest one, because we can only, in one of the sub array, we can only consider 155 as a smaller one. That's why. Understood? In one of the sub array, we can only consider 155 as the slowest or the lowest one. That's why in one scenario I have considered it. In another scenarios, I have not considered that 55 as the slowest one. Got it, Suraj? This will happen in all the duplicate scenarios. Wherever in one side you will consider it, another side you should not consider it. Okay. So that was all about the doubt. Anyone else has any doubt in any other questions? like sub array. This was, I think, sub array minimums, right? Stock span or histogram area, binding matrix, or the duplicate one, adjacent duplicate. Yeah, Raj. What was the problem in stock span? Similar question we has today also on the in one of the assignment. If you guys remember about the daily temperature, oh, you didn't understand. That was very nice, very easy question actually, Raj. Let me explain you. So there is one stock, okay, and we have seven, like we have the data of this stock for 5 days. Like on the day one, the price was 100. Day two, price was 85. Day three, price was 82, and day four, price was 75. And day five, the price was 110. Okay. So in the question they were asking, you choose any of the day in this. You choose any of the day, like day three if you choose. And after choosing that day, you have to go backside from that element, and find it out where the price was lesser or equal. Where the price was lesser and equal. So first time when we will start from this day three, price is already equal. Price is already equal. So day we already got one day. You have to count out all the days where price is equal or price is lesser. So here we can see price is equal. Now let's move further on the back side. Price is lesser or equal? No, price is greater. Price is lesser or equal? No, price is greater. So answer is one day. That's what the answer is here. Same goes for 110. You can see. If we talk about day 5, you need to choose that day, and you have to choose that day, and you have to find it. You have to go backward, and you need to find it out. What are the days where price is equal and price are lesser, and you have to start from same day. So you will check here. Yeah, price is equal always. For the same day, price will be equal. So 110, and then you will go into the back side. 75, yes, it's smaller. This is also smaller. So like this is first day, this is second day, this is third day, fourth day, fifth day. So for day 5, answer would be 5 day. 5 consecutive 5 days was price was smaller, and today it's increasing. Understood, Arad? That was the logic. That was the question actually. And you know about the logic which we discussed. You need to find out the greater element, and then you need to subtract it with the index. You study completely stack problem. Yes, Joseph. Will it be given in the question that one number should not be considered twice if there exists duplicates? It's not. It's a logical. It's a logical, Vishal. It will not given in the question. You have to not consider. You have to think about it. In the duplicate scenarios, only 155 could be considered, right? I've shown you this thing, right? In this question, you have to only choose 155. But in your sub-array, you have 255. Then you need to now decide which one I need to take in this one. So now that's why you have to write a logic in a way there you have to consider 55 only once. This will not mention in the question. This is your thought process. Understood, Vishal? That because see, these are questions, these are the some edge cases where we got the duplicate element. So how sub array will look like? In sub array, see, for this answer would only be 155, only one will be considered on this. And which one we have to consider? We can consider this one also, this one also. So that's why just consider one of them. So that's why in the logic, you remember, I have taken one of them at one place. I have taken 55 as a smaller. Whenever I am comparing 55 and the right side, and one of the places I am considering 55 as a smaller, and in other places I am not. It means in the same scenario, other 55 will not be considered as a smaller, because I have already considered this 55 as a smaller. So other 55 will not be considered as a smaller one. So that's why in one place I have only considered 55 as a smaller. Other places I have not considered 55 as smaller, and I'm just going at the end place, and which was the left side. You can do opposite also. In the right, when you are moving on the right side, you cannot consider 55 as a smaller one. Then this 3 will become 4. Then on the left side, you have to consider this 55 is smaller. Then only you will get the correct answer. Otherwise, you will not get the correct answer. Okay, so let's see. Sir, in stack, always follow four methods. Solution any question? Yes. So you have to like find while reading your question, you need to find like think about it. Are they asking about the first smaller one, or with that question you will get that knowledge. Let me show you one more question, very easy one. Similar like stock span. I already told you in the last class, which was daily temperature. Let's open this question in lead code. daily daily temperature, it was showing in lead code. As we see, right, daily temperature in Austin or daily temperature in US. So or in India or anywhere, so it was showing in lead code. Okay, there's already solved it, so that's fine. So okay, let's see. They have given it as a medium question, but it was very easy. Stock is similar to like stock span. So what they are saying, given an array of integer temperature, so this is the array of temperature, represent the daily temperature, which represent the daily temperatures. These are like same day one temperature, day two temperature, day three temperature. Return the array answer such that the number of days you have to wait after the ith day to get a warmer temperature. To get a warmer temperature. अब देखो क्या बोल रहे हैं? If there is no future day, then you just keep answer as a zero. If there is no future day which is warmer, then you just keep your answer as a zero. अब warmer मतलब क्या होता है? What is the meaning of warmer? It means कि ज्यादा गर्मी होगी उस दिन. Warmer means more hotter. Correct? That's what the meaning is there. Warmer means more hotter. So let's take their array, which was 73. So like on the day one, I think it's, I don't know which countries this temperature have, but let's see. So 71, 73, sorry, 73, it was 73. Might be in Fahrenheit, huh? 73, then 74, then 75, then 71, 69, 72, 76, 73. So now guys, these are day 2, day 3, day 4, day 5, day 6, day 7, day 8. They are saying choose any of the day here. So let's see if I'm choosing this of the day. Correct? And what they are showing, what they are saying, you have to wait after the ith day to get a warmer temperature. क्या कह रहे हैं कि choose any index from the here, which should be the number of days you have to wait after the ith day to get a warmer temperature. अब जैसे इन्होंने after बोल दिया, when they said after, it means they are saying you have to look onto the right side, and you need to look for that day where temperature is more warmer. So today it's 71. You need to look for the day where temperature is greater than that. Correct, guys? They are saying look for the temperature where it is greater than the current day. It means more warmer than today. So that's why you need to find it out, the greatest element at right. Greatest element at right. So we 0, 1, 2, 3, 4, 5, 6, 7. So if we just talking about the indexes, so I think we will get the index as a 5. Index as a 5. So we just subtract it. 5 minus 3 is equal to 2. You can see after 2 days, we will get the warmer temperature. And you will see answer for 73, 71, it would be, let's see answer. So for 71, the fourth index, which is 2, you can see it's 2. So that's very simple. You just need to find out, you just need to read the question, and based on that question, you need to think about, is this going to be, are we going to be able to solve it with the stack or not? So if you see that somewhere you need to find out the greater element on the right side, or lower element, first lower element on the right side, first greater element on the right side, or first first lowest element on the left side, first greater element on the left side. On those all scenarios, you have to go with this approach only. These 4 approaches. Everyone understood this way? Can we move on to the next question? Okay. This was easy, right? It was not a lot of thinking needed. Just read the question, whatever we have done it, do the similar thing. Okay, so second one is little bit like thinking needed there. Sum of sub-array ranges. Okay, so this one is also available here. Sum of sub-array ranges, not need code, it's lead code. Yeah, sub-array ranges. So this is also medium. And see, guys, this is also again going to be very easy question. Now, what they are saying, why this question is going to be easy? Because we have already done the sub-array minimums. We have already done the sub-array minimums. That's why this question is also going to be very easy. So they are saying you are given an integer array nums, and the range of sub-array of nums is the difference between largest and smallest element in the sub-array. And you need to return the sum of all sub-array ranges of num. And sub-array is a contiguous, non-empty sequence of element within. That's already we have discussed about the sub-array in last class. So let's take this example, 1, 2, 3. Very small array, 1, 2, 3. We already know about the subsets of them. Let's quickly see that. 1, 2, 3, 1, 2, 2, 3. Anything else? 1, 2, 3. Right? We have covered everything. 1, 2, 3, 4, 5, 6. Formula is n minus 1 divided by 2. So yeah, 3, 3, 6. And yeah. So it is close to 1, 2, 3, 1, 2. Yeah, 6 is there. Is it the right, guys? Let me ask you guys. Does this look good to you? The sub arrays of 1, 2, 3? Everyone? Yeah, okay. So what they are saying, guys, you need to find it out range, sum of range, and they are saying how will you find out the range? Within the each array, you need to find out the minimum and maximum, and then the range is maximum minus minimum. That's what. In the last question, if you guys remember, we have already find out the minimum, but this time you also need to find out the maximum, and once you got the maximum, you need to subtract it. So let's first find out the minimum in all the arrays. Okay. So for this array, let me write the minimum. Let me just copy it again. Let me write it, and then we will write the minimum for them. Again, the same sub arrays. 3, 1, 2, 2, 3, and 1, 2, 3. Okay, let's calculate the minimum in each array. So for here it's 1, here it's 2, minimum is the same number. Here 1, here 2, and here 1. Correct, guys? Let's find out the max also, which this is new in this question. 1, 2, 3, because in the sub array it's just one number. That would be minimum, that would be maximum. Here it would be 2, here it would be 3, here it would be 3. Guys, now if we add all those numbers, add it, add it, add it, add it. So let's see what we are getting here. So 3, 6, 8, 11, 13, and 14. If we add it, we'll get the 14. Let's add it here. 2, 1, 3, 4, 7, 9, and 10. Now what we need to do for finding out the range? Max minus minimum. 14 minus 10. And our answer is 4, guys. You guys can see that our answer is 4. So what do we need to do? In the last question, sum of sub array minimums. So in that array, from all the sub array, we find it out the minimums only, and then we added them. Correct? But here, what you need to do? You also need to find out maximum for that element on the left side and on the right side. As you find it out the minimum for same number on the left and right, now this time you have to find out the maximum also for that number. And once you find out the maximum and minimum, then you have to do the subtract. That's, you just add all the maximum, all the minimum as we did, and then you just simply do the subtraction, maximum minus minimum, you will get the range. Everyone understood the logic behind it, intuition behind it. That's why I was like giving more attention to this question when I completed the sum of sub-array minimums, because it was simple, similar question. So when you are practicing sum of sub-array minimums, you practice it, and after that go for this problem, sum of sub-array ranges. Okay, everyone? Anyone has any questions here? We just have to find the max one only. No, just not only that. We have to find out minimum first for that element. Then we have to find out the maximum for that element. If you remember the sum of sub-array minimums, we are taking the lowest, left on the left side lowest, right side lowest. Correct? Then you remember then what we are doing, from the right side lowest minus index, then multiply by original index minus left side index. That's how we got the minimum. How many minimum subset any number will make. Correct? That's what you need to, same logic, but the condition would be this time you have to find out the greater one. Yes, Joseph. Sum of sub-array minimums was taught yesterday. Yes, yes. Understood, Arad? We just have to find the max of one only. No, no, no. Not only. That's what. Only is wrong there. We have to find max, min, both. Then we need to do sum is equal to max minus min. Everyone understood? Yeah. So let's move on the third question, which was next greater element 2, which is also there. So this one is little bit interesting. This one is little bit interesting. Okay. So this is also comes into the medium. If you guys remember the last next greater element 1, that was coming in easy, but this one comes with medium. So why? So let's see that. So what they are saying, they have given a circular integer array. Okay. When they are saying circular integer array, it means the next element or the last element of array will point it out to nums 0, will point it out to nums 0. So you remember, let's take the same question, 1 to 1. Let's take the same array which they have taken in the example, 1 to 1. Okay. And if you guys remember, if we talk about the next greater element 1, उस सिनेरियो में क्या होता था जब हम एलिमेंट फाइंड आउट करते थे? So what we do, we look for the right side. Okay, so for 1, 2 would be the greater. I'm right now talking about values, not indexes, guys. So right now this would be 1. For 1, the next greater value would be 2. For 2 there will not any greater value, so we'll put -1. Same goes for 1. There is no greater value, we'll put -1. Correct? Everyone agrees with that? This logic we already know about how to do this implementation. Let me know in the chat. We have already done that. We've already done that, right? In the next greater element 1. Next greater element 1. Now, in the next greater element 2, they have enhanced little bit logic. They are saying it's going to be circular. It's going to be circular. So what does it mean? It means so earlier what we are doing, if you are not getting any element on the right side, we'll simply put -1 there. But this time, if you are not getting any greater element on the right side, we will start looking from the previous index also. We will start looking from the starting index, not previous. We'll start looking from the starting index. Let's take a better example. 2, 7, 8, 1, 6, 4. Okay, so first let's calculate next greater element 1. That was very small example. That's why you guys will not able to understand. So for 2, 7 would be the greater. For 7, 8 would be the greater. For 8, there is no element, so minus 1. For 1, 6 would be the greater element. For 6, there is no greater element, we'll put minus 1. For 4, there is no greater element. That was the next greater element 2. But guys, for next greater element 2, they are saying if you are not able to find it something on the right side, also look on the left side. Also look onto the left side. And then when you are looking onto the left side, always look from the starting index. Always look from the starting index. So let's see it. For 2, first we will look onto the right side. For 2, 7 is there. Okay, 7 is there. 7 will be the answer. For 7, 8 is there. 8 is there. Okay. Now guys, look for 8. For 8, there is no element on the right, which is greater. Which is greater, no element on the right. So what we will do after looking into these three numbers, now we will come back to the previous number, like the first index. We will come back to the first index and we'll look it here. Is 2 is the greater than is 2 is greater than 8? No. 7 is greater than 8? No. Again 8 is coming. So it means once we got the same element which we are looking, so we'll put minus 1. It means there is no greater element in the array after doing the circular also. After starting from the first index also, we didn't find any greater than that. So on those positions, we'll put minus 1. But let's look for 1. Earlier, for 1, yeah, 6 is there. But now guys, look, for 6, now again, we don't find any greater element on the right side. So now what we'll do, we'll come back to this place. We'll come back to this starting index and we'll start looking into this. Is 2 is greater than 6? No. 7, yes, 7 is. So now 7 would be here. Same goes for 4. We'll because there is no greater element on the right side. We'll come back to the starting index. Is 2 greater than 4? No. Is 7 greater than 4? Yes. So our answer would be 7. This is next greater element 2. Understood, guys? Everyone understood next greater element 2? Any doubt? Joseph is saying 7 for the last element, we'll check the first element. Yes. On not only the first element, we will start looking from the first element. Yes sir, no. Vishal is saying yes sir, no. क्या मतलब है भाई विशाल इसका? Yes sir, no. Did you get the question? Everyone got the question? Ah, oh, great. We can go in both directions. Yes, but Arad, the scenario is when you are looking into when you're saying both direction. So when we are talking about the left side, you cannot go from this side to like this. Other, if you will go for looking for 6, like looking for 6, there is no greater element. Then you cannot go from here to here. Then you will get 8 as the answer. But no, that's not the scenario. Scenario is you have to go back from the starting position. Go back from the starting position. Then you have to find out the first greater. So that's also one thing. But yes, that's true. We have to go into the both directions. But there is one condition, and they're saying that you have to start looking from the first index. Everyone understood? That's the O. Yeah. Otherwise, people will understand that yes, we can look back from the same element. No. For that, first you look onto the right, because this circular. They said this array is circular. They're saying this array is circular. So circular mean this -1 is pointing out to 7. That's the meaning of circular. Understood, everyone? So let's try to think about the solution for this. Okay, let's see. It seems like it was going like in both direction. It is going into both direction. Arad, it is going in both direction, but there is a one pattern to follow to go into both direction. It is going in both direction, but there is a pattern to follow for moving into both directions. Understood, guys? Everyone understood? Anyone has any doubt, any questions? No, right? Let's move into the logic part. So there are two ways actually to do that. People has given me two ways to do that. I will try to explain with both ways. You guys tell me which one is better. or which one you guys think better or easy to understand. Okay. So first thing they have given me this way. So see, this was like little bit different than the earlier approaches. So you remember, for always finding out the right greater element, we always start from the starting index. Or we always start from the last index. Okay. So let's talk about that one only. First, let's talk about that one, which I find easy also, and I think that will be, that approach will match with all of our earlier approaches also. So that's why I think that one only you should understand, because that one is easy also to understand. But let's see. So guys, let's take the same array: 2, 7, 8, 1, 6, 4. For finding out the next greater element, we always start from the right side. We always start from the end of loop. Correct? So we always start from this. और हम क्या करते थे? In the next greater element 1, what we generally do, whenever we are finding the last element, we keep -1 or the next index. Like for this index would be 0, 1, 2, 3, 4, 5, 6. Yeah, one of them, when we're talking about element, we keep it as a -1, and when we're talking about the indexes, we keep 6. Correct, guys? That's what we did in the next greater element 1. And talking about next greater element 1, that's how we start our loop from here, and then we go back and put it in a stack. But here scenario is little different. Here scenario is, guys, for this element, if we do not have anything this side, we need to look into this one, right? We need to look into this one. Correct? We need to look into this size. Agree, guys? Because we need to go back, because this is circular. So we might get answer. We might. I'm saying we might get answer onto the right side or onto the left side. Correct? Because this is circular one. That's what the condition is. We might get the answer on the left side. So guys, let's do one thing. Why not first traverse all the left side scenarios and put all the greater element into our stack. All the greater element into our stack. Okay, so let's try that first. Let's start first traversing this part of array only, and we will only do it first time, because just for finding out the last values and answer. Because once we got the last values answer, then with one stack only we will be able to because while traversing this much element, we will be having in that stack, we will be having all the greater elements there. So let's first traverse from here. So let's start traversing in the same logic. Let's start traversing from 6. So our stack is empty, put 6 here. Correct? Our stack is empty, put 6, or also take the indexes also, both scenario, both things. Why only take the number? We'll take bigger stack, another bigger stack. We'll take the 6, and what is the index also? 0, 1, 2, 3, 4, 5. So take the indexes also. So guys, the first one is the element, second one is the index, 6, 4. Okay. Now because our stack was empty, so that's why we kept it both. Now we have to move backward, right? So we have traversed this one. Now let's traverse 1. Is 1 greater than 6? If you guys remember, always in the greater scenario, I told you, array peak should always be greater. If array peak is greater, we will not do popping out. We will not do popping out. You guys remember that? You guys remember the greater element? I told you the logic. In the greater element, in the stack, peak is greater, we will not do popping. Same here. Right now you can see our stack peak is greater, so we will not do popping. We'll simply push the 1 here. Correct? Let's also push the index. Guys, this is index. Every time I am telling you, the second one is the index I am pushing here, and this one is the element. Okay, now let's move further. Look for it. Oh yeah, now you can see stack peak is not greater. Stack peak is not greater. Now what we will do? Why 6, 4? Joseph, 6 is element, 4 is index, 1 is element, 3 is index. Understood? Who was asking? Joseph. Understood, Joseph? 6 is element, 4 is index. Understood? Yeah, so we are pushing both because we have seen lot of problems. You have not joined. I know you have not joined the last class. That's why you are like you might be a little bit confused about why we are pushing indexes. But if you will see the last class recording, you will see that lot of places we were using indexes only. Okay, so now let's see. Now we have to do the popping for it. So let's do the popping. I think all the element will be popped out. All the element will be popped out. Right, guys? All the element will be popped out because 6 is also smaller, right? Agree? Agree, guys? Every element will be popped out because 6 is also smaller. So now 8 we will put with the index 8 comma 2. Now let's move further. Let's look for 7. 7, our stack peak is greater, so we will not push, we will not pop it anything. 7 comma 1. Let's look for 2. Yes, stack peak is again greater, so 2 comma 0. So now guys, once you traverse the this part of array, like one after removing the first element, you know what you are getting here. If you just observe these three numbers, if you observe these three numbers, can you observe what they are giving? Stack peak, stack peak is giving the first number here. Stack peak is always giving us the first number which is in the zeroth index, and then 7 is coming here, and then 8 is coming. You can see the greater element, like how we are, how like if we go from the left side, you can see how the greater elements are moving in that same value we are having in the stack also. Correct. So now let's complete the whole problem. Now we have traversed this part of array, right? And we got this stack. Now let's start again traversing from the first point, from here for 4. Okay. Now we have this stack already filled. Let's start traversing for this array. Starting from here. Starting from here. So now compare it. 4 is greater than 2, right? 4 is greater than 2. So now what we will do, guys? We'll do the popping in this stack. Correct? Because 4 is greater than 2. So we'll do the popping here. And our popping will stop at 7. Because 7 is greater. Our popping will stop at 7. Right, guys? Our popping will stop at 7 only. Everyone agree with that? Our popping will stop at 7. Right? So the 4 answer would be 7. For 4, the next greater element would be 7. Okay, now push the 4 also. Push the 4. Correct. Now let's look for 6. Let's look for 6. Next greater element. Now in the stack top 4 is coming. Again do the popping because 4 is smaller than 6. Do the popping. Now we got 7. 7 is greater. Okay. For this 7 is again answer. And now push the 6. Again, now for 1. Oh yeah, it's greater. 6 is our answer. Push 1 here. Right? Push 1 here. Same process. That's why I'm telling this one is easy. Same process we are following. 1 is here. Now let's look for 8. Let's look for 8, guys. So this is smaller. We'll go down. This is also smaller. This is also smaller. This is equal. We will remove it because there is no duplicate scenario, anything like that. Equal, we will remove it. So now our stack is empty, guys. Now our stack is empty. So when our stack is empty, what we do? We put -1 as our answer. And we will push 8 here. Correct? Now let's look for 7. Yeah, our stack is still greater. So 8 is there. And push the 7 is this place. Let's look for 2. Get the 7. So guys, what we do? We use the same stack in both of the iterations. But first time, first time we only iterated this much part. Less than the last element, less than the last element. This is one way people solve the problem, same problem, because they traverse this whole the remaining array after leaving the last one, and they got this monotonic stack, which was like, if you see from the top, it is incrementing. So it is just giving you from the, like if you go into this circular space, it's just giving you all the greater elements, 2, 7, 8. Understood? This is one way people solve this problem. Let me first come back to chat and let's see if you guys have any doubt. Suraj saying 6. So for 6 he is asking, I think. Right? Right, Suraj? You're asking for 6. This one. What you're asking then? Oh, you give answer. Okay. You give answer. Okay. So this is one way, guys. People do that. There is another way which people do that, which is little bit different than which we have done earlier. But I will explain that way also. 278 164. What they guys use? They use one stack only, right? Okay. So they stack one is then they use one stack. So we have also used one stack only here. We have also used one stack. But in one iteration, they start from I is equal to 0. They will start from here 0, and they will go 2 time of n I plus plus. They will go 2 type of f1. Like there are 5 elements, right? 2, 1, 0, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. 6 elements are there, right? So they will put a loop 12 times. They will run this loop 12 times. इससे तुम समझ पा रहे हो कि क्या करना चाह रहे हैं. With the 12 times, you might be able to think about what they are trying to do here. They are trying to traverse each element 2 times. They are trying to traverse each element 2 times. And how? Let me show you. What guys they are doing? They are just writing a logic like this: I mod n. So first time I would be 0. We will be looking like that. Okay, this is the first element. Push it in the array. Push the index. Push the index also. Here they are using the index in this example. This is a little bit like different understanding than we did earlier, but this is also one approach, guys. We'll push the index here, 2, 0. Okay, because our stack is empty. Now I is equal to 1. Now I is equal to 1. And their condition was also I mod n every time. Yeah, so I is equal to 1. So 1 mod n. So now because our stack is full and we are looking for element 7, so you can see we need to do popping, right? We need to do popping because this is smaller. Agree, guys? This is smaller. So no, their while condition. Their while condition is like this: while stack dot length is greater than 0. This one we also have. And they are looking for stack peak should be lesser than or equal to array of, we are considering this as an array of I mod n. So you can see it's right now this is lesser, so we'll do stack dot pop. You guys remember this code, right? But the important thing is this part, I mod n. You remember all other lines, but this part is important, I mod n. See what is the purpose it is serving? It is serving once you will traverse all the arrays like 0, 1, 2, 3, 4, 5. Once your I will become 6, now you will again check for I mod 6, which will give us 0. So once your I is equal to 6, but in the array you are going to check for array 0. Then your I will become 7. Then you will do again I mod 6. Then you will again check for array 1. That's what the purpose is. You again will check for array 2, array 3, array 4, array 5. And then your loop will stop because you have reached to I12. Correct? Here it will be I is equal to 8. Here I is equal to 9. Here I is equal to 10. Here I is equal to 11. And there you will stop because I will become 12 and your condition will stop here. So that's what they are doing, and they are continuously checking all those things. And once you will traverse all the elements here, guys, with the stack, I'm saying that you will get the answer there also. But this is little bit different way. That's why I will personally prefer this one, the first one, because we already know the code and everything there. I mod n will also work in the same way. And I tried with both ways. Both ways are like submitting the answer and everything is working. Let me show you the code I was telling you, the first one. This is the first one code. So where I'm checking if n is equal to 1, because the number could be 1 also there. So simply we need to return -1, because if there is only one number in the array, like if somebody is providing you 4 and asking you to find out the greater elements, always -1 will be there. So -1 is there. You can see I'm starting my loop from n minus 2. This is the loop. I'm starting from n minus 2 from this element 6. Then I'm pushing simply all the stack, doing that similar logic. Wherever nums is greater, do the popping. Then I'm again using the n minus 1 loop and then doing the popping. If answer is less than, pushing this, not, then pushing the element. And at the end, every time pushing the nums comma I. And this answer was fully working. It has submitted. If I submit it, you will get the answer here. Yeah, this one is this. And I think this one is the other one. I tried both scenarios. The mod one also I tried. No, actually this one is the same one. I think in the code repo, I have both. Let me show you. In the code repo, if I go for next grid element 2. Oh, actually I don't have the second one. Okay, I will write the second one for you guys in the same repo. But yeah, the first one is easy. I would suggest to you guys. Yes, first one is relevant. This is just submitting and every answer is giving. Okay. Second approach, actually, what is happening? So in second approach, what they are doing, they are using I mod n. I mod n. So what will happen? First, you will traverse all the array 2, 7, 8, 1, 6, 4. Similar way. 2, okay. Then go for see. 2 is there, 0 index is there. Correct. Now 7 is coming, right? So you will pop it this. Before popping it out, in the answer array, whatever index is there, 0. For the 0 index, keep the 7 as the answer. That's what they were doing. Keep the 7 as the answer. Whatever index you are popping out, for that, keep the current answer. Keep the current element answer. Because you are looking for 1, right? Looking for 7. So keep the 7 here. Now pop it out. Now you pop it out. Now put the 7 here. 7 comma 1. Correct? Now let's look for this one. 8. Again our element is greater. Again our element is greater. Again we need to pop it out. But before popping out, in this index, keep the 8. Keep the 8. So for one index, keep the 8. Okay. Now pop it out. Now pop it out. Now let's keep our 8 here with the index 2. Okay. Now we are getting the lesser element. We'll not pop it out. We'll put 1 comma 3 here. Correct. Again we are getting 6. So now element is again greater. Again element is greater. So what we need to do here? At the we need to pop it, right? We need to pop this one. And before popping, at the position 3, at the position 3, keep the current element, which is 6. At the position 3, keep the element 6. Correct? And then push your 6 here. 6 comma 4. Now let's look for 4. Oh, okay, it's not 4 comma 5. Keep the 4 comma 5 here. Correct? Now now your I will become 6. Again you are going for 0. So again you will start looking from 2. Your element is get lesser? No. So 2 comma 0. Correct? Let's move further. 7. 7 is coming again. 7 comma 1 is again greater. So just pop it out. Again for 0, you will keep the 7, which we have already kept it. So no need to take this one. Go for 4. Go for 4. You can see 4 is again smaller. So in this index, keep the 7. So now at the 5th index, 7 will come here. At the 5th index, 7 will also come. Correct? Now we have already found out the 7. So push the 7 also. 7 comma 1. Okay, first we pop it out. First pop it out. Oh, 1 minute. 7 is smaller here also. For this index, 7 is also smaller. So for 4, 7 will also come. 7 is smaller here also. So pop it out this one also. Okay. Now 8 comma 2 is there. Yes, that's fine. 8 comma 2 is there. Now they are equal. You can see they are equal. So now we'll pop it out. We'll pop it out this one also. And here, when both are equal, we can keep the -1. we can keep the -1 here. When both are equal, we can keep the -1 at this place, and it will continue. This loop will continue. 1 comma 1 comma 3 will come, which is smaller. So at the which is again we will not do anything. 1 comma 3 will come, then 6 comma 4 will come. 8 is already greater, so 6 is already. We'll do again the popping. Yeah, because 6 is greater, right? But because we have already filled our answer array, so 3 will again be 6, correct? Again go for 4. 6 is already greater. We already filled the answer. This could be our answer. See, 7, 8, -1, 6, 7, 7. So we have to do the popping it out, and whenever while we are doing the popping, whatever index we are taking, on that index take the current element. Take the current element. That's the code is going for the second iteration. The code is available actually in there or not? Okay, I will push the code for second one also if you guys are interested in the second approach. Okay. Suraj wants to see the code for first one. Yes, Suraj, this is the code for first one. This is the code for first one. If n is equal to 1, return -1. We have a stack, we have answer. We started from n-2, just simply pushing and popping in stack, not keeping anything in our answer, right? And once we have completed this loop, we have already figured it out, the monotonic stack which we will get, and then we are starting from n-1 and then checking this earlier stack and then pushing our answer also this time. You can see these and these line are similar than the earlier because we are simply doing the stack operations. But this time we are also pushing our answers in also pushing the elements in answer array. Understood? Line 15, less than equal to. Line 15. Yeah. So wherever our nums is greater than stack peak or equal to stack peak, we have to do the pop. Wherever our number is greater than the peak, we need to do the popping. Correct? That's what the logic is. Understood, Suraj? Sir, I copied the entire array twice and then simply call the next greater element unique function on the array of size 2 to power multiply n and use the slice method to use as return out of the array. But I think if you want to go with the 2 to power n, I think this I mod 1 is nice in that case. I mod n way is nice in that way. It will just traverse 2 times the whole array, but definitely it's easier one to understand. It's easy to understand the second approach. If you really want to go with the 2 multiply n that way, with a slice and all that, it is using a lot of, I think, array methods, right? Understood, guys? Both of the ways, both of the approach. In the second approach, in each index, in second approach, in each index, we need to do the mod. And when we are popping it out, and you guys know when we have to pop it, you have to only pop it when your current element is greater than the stack peak. At that time, you have to peak. At that time, you have to do popping. And while you are popping it out, so whatever element you are popping it out, at that element index, keep the current element. Keep the current element. That's the code only you need to use for this one. So you can use stack where you are seeing like you have to go into one way, like something is incrementing, something is like decrementing. In those scenarios, I think stack is better. Correct? For all those problems, stack is better to use in those scenarios. And in these problems, like you have seen, like next greater element, sub array minimums, sub array maximum, some of sub array ranges. In those problems, I think stack is going to help you a lot. Okay, guys, so that's all about the stack. Let's move into today's new topic. Okay, and I think I will push the code for you guys. 1 minute, guys. Keeping inventory one of the most important things you can do is maintain logged. Okay, so I need to do update, but can I do it little bit later? So let's keep it down. I'll do it after class. Okay, so that was all about, guys, stack. And I am again saying to everyone, please practice all the problems. Please practice all the problems. Whatever you guys are doing, do not just keep the hold there for some time and keep practicing these problems, because these problems are very easy, and some of the problems are has been asked in the Google or in the Amazon or Flipkart, big companies. So that's why we'll try to solve. If you will practice these problems, you will have like thoughts in your mind, and when somebody is going to ask you this tough question in interviews, you guys can easily crack it. Okay. So with that, let's move into our today's topic, which is very easy actually. Similar to queues, similar to stack, we have queue data structure also. Similar to stack, we have queue data structure also. So you guys remember, we have taken one example for stack, right? The chair example, or the plates in our marriage hall, correct? Or books example we have seen, correct? Those were all the stack examples where we can pick the where we have to. If we talk about the plate scenario, so we have to first pick the first plate, then the second plate, then the third, then the fourth. So this is the stack scenario where we say that whoever is coming first, whoever is coming first, that person will go last. That person will go last. So the first plate who has been kept at the bottom, that plate will be used at the end only. Same goes for the other example which we were talking about. What was the other example we were talking about? The chair example. Yeah, the chair example. The first chair, on the top of that we are keeping all the chairs. So the first chair which was there, that chair will be used at last only. Or second scenario, same thing you can say in other way. Whatever the last chair we are keeping on the top, that chair will be used first. Correct, guys? So that's why we have created one formula there or mantra there, and that mantra was last in, first out, first in, last out. Correct? That was all about the stack. That strategy we are following right now. Always in stack, element is coming from the top, and the element which is in the top, that will only be go first. Correct? In stack, we have two main methods, which was push and pop. Push for inserting an element, pop for deleting an element. Correct. Then we created some other methods like peek to get the peek element. Then we created that one actually. What do we say? Is empty method we created, right? Yes, empty one is empty method we created. And I remember print method we have created if you want to print the element of a stack data structure. Correct? Yeah, we have created insert at bottom, we have created the reverse, we have created the sort, lot of method we have created. Similar way, today we are going to jump into, guys, the queue. I think this is very like common term also. You guys have seen a lot of places people say that there is a queue. In English, they say that there is a queue. You have to go and stand in that queue to get cylinders. Cylinder, if you go for getting the cylinder, so you will see that there is a one queue. Correct? Even for like a lot of places in real time example, you can say like for taking the ticket in the movie hall, you have to stand in queue. Correct? Taking an order in your like Burger King or any of the outlet, you have to stand in the queue. Correct? And even in the like if we talk about the road traffic, so also you will see if there is some traffic or there is red signal, all car stand in the queue. Correct? So I think these are very real life example where we have already seen queue. Correct? So that's what the queue is, guys. If we just try to observe this queue, if we try to observe this queue with a movie hall example, if you want to collect a ticket for any new movie, so whoever is the first person in the line, whenever the ticket counter will open, that person will get the first ticket, right? Whoever is in the first in that queue or line. See, in Hindi or I don't know in other languages, but in Hindi हम mostly कहते हैं कि line में खड़े हो जाओ, right? We say you just stand in line, and that line is nothing. It's just a queue in the technical language, or in the I think Western word or somewhere they say it as a queue. Correct? In our words, we just simply say line में खड़े हो जाओ. Correct? So that line is nothing. It's a queue. So whoever is standing first in the line, that person will be getting anything. Like it means like if somebody is coming standing in the line for movie hall, that first person will get the ticket. If somebody is standing for any prize in the first line, that first person will get the first prize also. So that's what, if you observe this behavior, so you guys will see that with the data, if we talk with the data context, so whatever data is coming at first, whatever data is coming at first, that data will go out first. That data will only go out of that queue first. Correct? And always in the line, if there are 5 people standing on the line, always a new entry will come. He will always stand after 5. Correct? He will always stand after 5. Correct? So like see, you guys already know that, but I'm just trying to tell these things with a little bit example. So there is person A, there is person B, there is person C, right? And there is person D. Now 4 person are standing in queue, and this is our movie counter or ticket counter, we can say. Correct? So once this ticket counter window will open, right now it's closed. So right now it's closed. So this person is standing at the first position near to the ticket counter. So this person will be getting a new ticket. Whenever this ticket counter will open, this person would be the one who will first get the ticket, and he will go out of the queue. He will go out of the queue. Then only once the A will got the ticket, then only the B will come first at the first position. Correct, guys? So you can see in queue, you observed one behavior. In queue, you always observed one behavior. Whoever is standing at first position, whoever is standing at first or front, we say it front also, guys, because you can see he is standing on the front. So who is standing in first or front, that person will go out of queue. That person will be the first, go out of queue. Everyone agree with that? They have also observed this thing. Yes, opposite to stack. They have also observed this thing, right? Now there are 3 people are coming. Now E is also coming. The new person is coming. So where he will stand? He will not stand at the first position or in the middle. He will always stand at this position. Correct? He will always stand at the last position. Correct? He will always stand at the last position. So second behavior which we observed in the queue, if a new person or element wants to be in a queue, if he wants to be in a queue, he has to stand at last, or in some way we also say rear. Rear is also last, rear window. You know, if you have the car, so people say that it's a rear window, means piche wali window, rear window, or front window. So that rear means at the last. Okay, or that's what behavior we can observe with a queue. Okay, so somebody has observed this behavior and they created one data structure with that. Okay, that if somebody wants to use this behavior only, so they should not they should directly use inbuilt. They created a queue data structure in the memory. So you just need to initialize queue and whatever variable you are getting, they will have these behaviors in queues. So that's why, guys, queue is similar to stack. It also follows that linear data structure approach, and bus just the pattern is little different. In stack में क्या था? Whoever is coming last, this person is coming last, this person will go out first. In the stack, this person will go out first, but in the queue, this is not the case. In the queue, whoever is coming first, that person will go first, like first come first basis. You can see lot of places, in lot of interviews or lot of webinars, they say that, right? First come first basis. That's queue only. They are saying you have to stand in queue. Everyone understood these little bit like real life relation between queues or little bit comparison with stack? Understood? Okay. Now, guys, queue also has similar methods like stack. So for insertion in stack, what method we had? It was push, right? For insertion, it was push. And for in queue, for insertion, method name is enqueue, means enter into queue. Enter into queue. Method name is enqueue. Okay, and in stack we have pop method, which we were using for deleting any element from the stack. Same way, for deleting element in the queue, we have dequeue, delete in the queue, or delete element in the queue, or discard, whatever you want to say with the. So these are only two important methods, same like stack. These are only two important methods. And in the stack, we only have one pointer. You guys remember? In stack, we only have one pointer. And what was that pointer? You guys tell me. In stack, we only have one pointer because in stack, entry जो entry हो रही थी in stack, entry and deletion both happening from the same place, which was on top. Correct? Entry भी top से हो रही थी और deletion भी top से हो रहा था, right? But in queue, it's not the case. In queue, this is not the case. In queue, there are two pointers. One pointer will tell from where you have to delete. For first pointer will stand here. He will always tell you this is the element which has to now go out. This is the element which has to go out. And there will be one more pointer here which will be telling us this is the next position where you can insert. This is the next position where you can insert. This is the next position where you can insert. So that's why in queue we have two pointers. Sometimes people say that a front, this pointer as a front, where from where we will do the deletion. People say it as a front, and other one they say it as a rear. Do the insertion at this position. Or you can say that rear as a last or front as a first. Anything according to you. But generally, like in the Java or any other language, they are saying it as a front and rear. If you will use their methods, if you will use any default methods, they are using it as a rear and front. Understood, guys? All these four things: enqueue, dequeue, rear, front. Everyone understood this? What about others? Vishal says yes. Suraj says yes. Can you repeat once more? These four things, right? Arad? Yeah. So see, Raj, in stack for insertion we have push method, correct? In queue, for inserting any element in the queue, we have to use enqueue method. Okay. For deleting any element from a stack, we use pop method, correct? For deleting element from, we use the pop method. In queue, we use dequeue method. Okay, we use the dequeue method. It will do the deletion for that element from the queue. Okay. Now, in stack, If you remember about the stack, this was a stack, and every time insertion or deletion, everything was happening from top only. Whatever element is in the top, so जो भी नया element आ रहा है, we will keep it at this position and then we will increment our top. And if you want to delete it, we will always delete it from the top and then reduce our top. That's what we were doing in the stack. In similar way, in Q, it's opened. It's open from two places. This stack has now this stack. If you turn this stack 90-degree clockwise, this will stack look like this. But now this time, this stack is open from both sides. So in this stack, we can only insert from this side and go out from this side. So that's why from where we are inserting, we are saying we are inserting from last, because in Q, we always insert from the last. So we can say it is rear slash last. And from where we are going out, we can say it as a front slash first. So that's what the variable name I was telling you, front and rear. Understood, Arad, now? Front and rear, what they are signifying it. Okay. Okay. So now quickly, okay, guys. So in this example, they are using this one, front as a 0. You guys want to use a front as a 0 or -1? Which one you guys are familiar in your college? Because I can go with both, 0 and -1. But in your college, which front as a 0? Okay. Because we tried last time as a top as a 0, so you guys were not comfortable with that. So let's start front as a 0. So now if we are saying that front is a 0, so it means we are saying that front will be pointing out to the element which is going to be delete, and rear will be pointing out to the position where next element has to insert. Okay, so now rear and front. So front will be pointing out, or it will keep the value or index pointing out the place which has to delete, okay, and rear will be pointing out the place where next element has to insert, okay. Are we good with that? Let me see in the slide if I'm missing anything. So this one we have already completed, so we can close this one. Yeah, we've already discussed assignment questions. So we have already discussed about the introduction of queues, already discussed about the operations, DQ, front, rear, NQ. Okay, yeah, let's. So similar way, guys, as we have discussed about the stack, we can implement stack with arrays or with linked list. With both of the things we can implement it. Okay, because these are very similar operations. So we are going to use the arrays for implementing the queues in JavaScript. We are going to use arrays for implementing queue data structure in JavaScript. Similar way as we use arrays for implementing stack in our previous classes. In similar way, we are going to implement queue with arrays, but we can implement it with the linked list also. When we want any dynamic memory, we can use the linked list there also. Okay. So let's now try to create a class similar like stack. Let's try to create the class. Let me see if they are starting with class only. Okay, there is nothing else we have missed out. So let's start with creating the class. Already created it, but I will delete it, and let's create a new file under the Q folder. So guys, the branch is Q. Okay, the branch is Q. What changes I did here in next greater LL? Oh, nothing. Guys, all the stack questions, all the stack assignment question, you will go get it into the stack branch of that repo. And now I'm starting a new branch for Q. So this is the Q branch you will get in the GitHub repo, and all the Q related changes will be there. Okay. Let's under the Q, let's create a new file, q1.js. Okay. Let's try to create a class for Q. Okay, so we'll create the constructor. This constructor will have three things, right? One is the data or item, whatever we want to say, and we are taking array, so we are taking this array, and then there will be top or no, we will say front. Front, we are initializing with 0, rear also as a 0. Both are initialized with 0. So now you can see in the array, because we are talking about one array, because we are saying that we are going to take our queue as an array. So in an array, this is the index of array, and right now front and rear both are having value as a 0. It means they both are pointing to this index, front and rear. So guys, whenever I'm saying pointing out, it means they are going to have the index value. Okay, everyone understood this thing? Whenever I'm saying pointing it out, it means they are going to have the index values. So from now I will simply say that front is pointing out here, rear is pointing out here. Everyone will be understood. Everyone will be able to understand that they are going to keep the index values. Everyone. What about Joseph and Arad? You guys understood? Whenever I'm saying in the pointing it out, it means they are going to keep the value of that value of the position of or index of that position. Agree? What about you, Joseph? Understood? Joseph, I'm waiting for your reply. You are still in the call. I think some network problem might be on the Joseph side. Okay. So let's move further, guys. So this is the initialized queue. So we can say this is the queue, correct? Now we need to, in the queue should have some default operations, right? Queue should have some default operations. So the default operations are enqueue for inserting, and then we dequeue. We can create a queue as a capital, or that's fine. Let's see, 1 minute. Let me see in the Java what is the method they have in the capital or in small. Queue in Java. In JS they do not have anything like that. That's why I need to go into the queue. Peak is there, remove is there. What about the insertion, guys? Add. They are having add as a method. Okay, they have the add as the operation, but okay, whatever. I can take enqueue small also, that's fine. So here we will be inserting an element, correct? And here we will be deleting it. Anyway, we are creating our custom queue, right? We are creating our own queue. So whatever name I want to give it, I will give it. Okay. So now guys, for insertion, it's very easy. So now first visualize it, then we'll do that. Now this is the scenario. Our queue is empty right now. Our queue is empty, and now we can say front and rear both are pointing to 0. So what I said, always whenever the new insertion is happening in this queue, it will always happen from the back side. It will always happen from the back side. So now we can say we are trying to do enqueue 4. It means we are trying to push 4 into this. So once we will push 4 here, we will increase our rear. Will increase rear to 1. So rear will now pointing out to the next position where the element has to insert. And front will still point out to 0. Front will still point out to 0, and front is telling if there is no other enqueue, if there is no other if there is no other person who is coming to this stack or in this queue, not in the stack, if there is no other person who is entering into this in this queue, so this would be the first person who will be going out. So that's why front will be pointing out to 0, and rear will be pointing out to 1, because rear is saying that is pointing out the place where next element has to insert it. So that's why rear is the pointing out that place where the next element has to insert, and front is pointing out the place which has to delete. So right now 0, it is pointing out to 0. It means this element has to delete. Understood? So how we will do that? We do this dot data, this dot rear, because we are always going to insert it from the rear, and then our value there, and then we will increase our this dot rear plus plus. Correct, guys? That's how our rear and this will look like. And let q equal to new q, right? And let's do the insertion in this q. Let's take a small, why this much big q? Q only. Q dot and q, and put the 4 here. And let's look into our q. Console.log q. Let's run it. Node q q1.js. You see, in the queue, one data is there, and our rear as the first position, and front is as a 0 position. Agree, guys? Agree, guys? Would always point to 0. No, no, no. When we will do deletion, front will always point to the element which needs to delete. Guys, front and rear. Understand? Very nice. Just keep it in your mind. Front will always point out to that element, which element we need to delete. Not always point to 0. It will point out to that element which needs to delete. And rear will always point out to that position where next element has to enter, where next element has to come to insert. Okay? You can see if we have 4, 5, 6, 7, 8. If this is the queue, right? And till now we have not deleted anything. So it means front will always point out to this element, which would be 0. Correct? Right, guys? Let's understand first front and rear nicely. Okay? Or yeah, let's delete it. Let's try to insert them one by one from the first scenario. We will do the coding later. First, let's understand this. Okay. Now this is our queue, which is empty right now. Front is pointing out to 0. Rear is also pointing out to 0. Okay. Now we got NQ 4. Okay. NQ we got. Now we have to insert it from back. Rear is right now both are at same place because our queue is empty. So now we have inserted the 4 here. Correct. Once we insert it from the back, now our rear become 1 and front is still 0. Because rear is telling us this is the next position where we have to do insert. Now again do NQ5. So you are telling this is the first index where you need to insert. So 4, 5. Now rear has become 2. Front is still 0. Because we have not deleted anything. Front is still 0. Now again NQ6. 4, 5, 6. Still rear is as 3. Just visualize these things. Front is equal to 0. Again NQ7. 4, 5, 6, 7. Rear is at 4. Front is at 0. Still. Okay, guys. Now we want to delete something from this queue. Now there are 4 people as standing in the queue. Like you can just in the queue, you can visualize like this. 4 has been entered, 5 has been entered, 6 has been entered, 7 has been entered. Now we want to delete. Now this 4 has to be go out of it. So now for deleting out, we will be always looking for our front pointer. Wherever our front pointer is, that element can only be deleted. So right now front is at 0th position. So only 4 can be deleted. So first we do DQ. So now 4 will be deleted, 5, 6, 7 will be there. Rear will still be at the 4th place, and front would be at 1. Front would be at 1 position. Okay, guys. Now we again do the DQ. Front would be at rear will still would be a 4, front will be at the second position, because you can see this is the second index which we are going to insert. Okay guys, while deleting it out, okay, let me draw it a little bit better also. So while deleting it out, we are doing like this. We are keeping 0 at that position while deleting it out. So that's why you might get confused with the index part. So we are not changing size anywhere. That's why our rear is still 4. We are not changing anywhere anything like that. In the same queue, these positions are empty right now. These positions are empty right now. Now if we again do the DQ, it will look like this: 0 0 0 7, right? And rear is still 4 and front is at 3. Correct? And now again, if you do the DQ, 0 0 0 0, and again rear and front is equal to 4. Now our queue is empty. This is how queue and front is working, guys. This is how rear and front is working. Understood? It will be filled with 0. Yes, it will be filled with 0. Yes, that's why front is changing. Because front is always going to point what is the element which we need to delete now. So now with this scenario, I think you also got wherever rear and front are equal, it means our queue is empty. Wherever rear and front are equal, it means our queue is empty. You can see in this place also and this place also. Both place our queue is empty. Both place our queue is empty. There is no element in the queue. And I'm not considering 0 as an element here. I'm just considering this as an empty place. Empty place. I'm not considering 0 as an answer here. At 0 as any element. You can keep null also. In this place, you can keep null also. You can keep anything here. Do not consider that 0 as a element here. Just consider that as an empty space. Okay? Yeah. So see, now you got the empty condition also. So if somebody is asking for what will be the empty scenario for Q, so that scenario would be return this dot front equal to this dot rear. Wherever both are equal, it means it's empty. If it's not, it will give us false. So this is the empty scenario. Okay. Now let's look for DQ, guys. What is happening in DQ? So we are first going for the front element. So let's front element. We're taking the first element index, which is this dot front. Correct? This will give us 0. And at this place, we can keep front index, or index we can write simply index. Index, we are keeping at that index null, empty. It's empty place. And then we are doing front plus plus. And we are doing front plus plus. This dot front plus plus. Understood, guys? This is DQ. At that position, we kept the null. Wherever right now front is, I am not keeping the 0 now. I'm keeping the null. Otherwise, you guys will confuse. What will happen if we insert the 0 only? So that's why I kept the null at that position. Wherever we are doing the deletion, we are simply putting the null at those places. Everyone understood now? These 4 operations. Let's put the print also. Print. So we need to print. So let's take our data, which is in this dot data, and we need to put a loop inside it. So let I is equal to 0, I less than this dot data dot length, and I plus plus, right? And you can here look for if this dot data console dot log. Oh no, this data I, yeah. If that at that index, if we have data, please print it out. Q element. This dot data I. Okay, so let's Oh, I have not used data. I directly use this dot data. Okay, that's fine. Okay, let's do some more NQ. Similar like this. Let's see this one how 4, 5. Do some more NQ 5, 6, 7. Okay. Let's now do the DQ. Spelling is correct. DQ, yeah. Let's do one more DQ. Okay. Now let's see our Q. How does or print? Let's call out the print. Okay. Q dot print. You can see 6 and 7. Only two elements which are right now on the Q are there. You can see 4, 5 has been already popped out or DQ'd. Everyone understood? Understood everyone? Now let's see if there is any other method which we have in the queues. NQ is there, DQ is there. They're saying you can do the similar with linked list also. If you want to do the NQ operation, so you have to add. So linked list operation, we have already seen this, right? Prepend, linked list operation prepend, where we want to add our element at the head position. So that's what the NQ operation. For the DQ operations, I think it would be remove from the next. Yeah, remove at last. These are the linked list operations. Okay, they do not have any other options. They are starting the next topic, which is DQ, which will start after break. But before that, we can also create like peak here. If somebody wants to know the peak element, so like see in the queue, who will be the peak memory? 1 minute. Queue is dynamic memory. Dynamic memory. Suraj, for generating a queue, what are we using underline? Is those things are dynamic or not? For queues, what are the two ways as I told you to implement it? This is, you tell me, Suraj, what are the two ways no, not data. Data is everywhere. For implementing a queue, what are the two ways I explained you? Front and rear for insertion and deletion. I'm talking about implementing queue. Front and rear just for insertion and deletion. In the rear, you will do insertion. In the rear position, you will do the insertion. From the front, you will do the deletion. But for implementing queue, what are the two ways I told you? Anyone else except Suraj? Anyone wants to answer it? Yes, Deepikanta has given correct answer. Array and linked list. NQ and DQ are insertion and deletion operations, guys. NQ and DQ are queues operation. Yes, array and linked list. These are only two ways which with them we can only implement queues. So now you tell me array are dynamic memory or linked lists are dynamic memory. Whatever way you guys are implementing, that would be the dynamic memory. Understood, Suraj? Yes, it's linked list. So linked list, if you will implement your queue with linked list, then it will follow the dynamic memory allocation. If you're using implementing your queue with arrays, it will follow the static memory allocation. Understood? Yeah. So with the implementation, these terms are generating like this. We can get that right. Okay, so guys, we can create the peak also in the same queue. One more method we can create peak. So you guys tell me. You guys will tell me. Just think about it. In the queue, what do you say as a peak? If there are 4 people standing in the peak, which one you will say it's the peak one? Queue at front. Yes, starting person. Queue at front. So always whoever is standing at the front will say that that's the first person. queue देखो queue, just visualize the queue, and in that queue, whoever is the first person, that person is going to get out of that queue. Yes, starting person. So that's why wherever we are having front, if somebody is saying that to give me the peak element, you just need to return the front there. It would be first we can check if it's not empty. If it's not empty, if our queue is not empty, so just simply return this dot data, ah, this dot data, this dot data, and this dot front. Whoever is standing on the front, just simply return it. Understood, guys? Okay, in stack we have two operations, underflow and overflow. We have similar operation here also. Underflow and overflow. We have similar operations here also. So if our queue is empty, if our queue is already empty and you are trying to still dequeue something, so it will throw the error. It will throw the error, and that error will be known as underflow condition. If our queue is empty and you are still trying to delete something, the error will be known as underflow condition, underflow scenarios. Or if your queue is full, like if your queue size is 5 and you have already inserted 5 element and you are trying to insert sixth element, it will throw the error overflow. Same like stack. Same like stack, these methods are similar here. Stack and queue does not have much differences, I would say. And at the end of class, I will give you one question, which is very nice question. When I was in college, I think that comes in my exam also. Very nice questions. Very like very interesting question. Actually, you can just think that question as a game, and that question is: can we implement queue with the help of stack? Till now, I told you implement queues with array and linked list. Do not tell the answer. Do not tell the answer right now. But see, I told you, Suraj, when you were asking these things, or Arad, whoever was asking, I told you we can implement stack with the array and linked list only. But with the array, we can create stack also, right? So you guys need to think about, can we implement queue with the help of, yeah, I also got the question in college. So you have to think about, can we implement queue with the help of stack, and vice versa also. Can we implement stack with the help of queue? These are very, I don't know, a lot of interviews also they ask. I think in one interview they have only asked me this question, because this is very common question in colleges. You can understand, right? If somebody is knowing these questions in colleges, so you can understand this how common this question is. So you guys can think about it after this class, that do not see the answer. I think Likit has already given some hints to you. It is just a hint. So just take that as a hint and try to think how. Okay. So that was all. Let's go for break, and then we'll come back and understand dequeue. It's a sub part of queue. I was sharing on screen there, right? In the queue, you can see in the Java, you can see this diagram, right? So in the queue, dequeue comes and priority queue comes, and you can see we can create dequeue with linked list also, or array dequeue also. Same way, array and linked list. So dequeue is a part of queue, and there is one priority queue also. It's all has same proper, it has all same meaning, but they have some extra features to you, which we will talk about after break. Dequeue and priority queue, in the here only they have dequeue, but priority queue is also there, which Java has, just the extended version. That's why you can see they have separated it out, like they have implemented priority queue class differently. But queue and dequeue are standard one. Priority queue, they have just customized it according to some special cases. According to some special cases. I will just theoretically tell you, but dequeue we will implement it. Okay, so let's go for break. So right now it's 11:45. We'll come back at 12. Okay, guys. Okay, guys. We'll come back at 12. Fine. Oh yeah, please respond. I thought I, you guys are not able to hear me. Okay, so let's come back at 12. Okay. Hello guys, can you guys hear me? Everyone back? Let me turn off the camera charger. So Vishal is back. Likhit is also back. What about others? Arad, Joseph, Ekta. Who else is there? Suraj, Vivekanta. Today actually very less people has joined. Oh, weekends. And I think Nilanjan, I remember about Nilanjan, he has office today also. Not sure about Deepak has joined or not. Might be Deepak also has some office today. Let me share my screen. Can you guys see my screen now? Yeah. So let's wait for one more minute and then jump on the next topic. So, in meanwhile, let's just summarize whatever we have done in today's class. Okay. So I think we started with our stack problems, stack assignment problem. So we started with I remember temperature one. It was very easy, similar to stock span. Then we jump onto sub array of regions, some of sub array regions. That one we discussed, and we saw some of the similarities with that question and the next one, the one which we have done sub array minimum. We have seen a lot of similarities there. Then we have seen the next question of next greater element two. We have seen two approaches for that. We discussed that those both approaches, and after that we started a new topic which was Q. So I've given a lot of real time examples for Q to you guys, like the cinema hall ticket, or in the class, or in the cylinder line, any of the, and wherever you are standing in the line, somehow it becomes Q. Okay. Then we talk about the operations in the queue, which are very similar to stack operations, push and pop. And in the queue we have NQ and DQ, which simulate the same thing, insertion and deletion. Then in the stack we have talked about there was only one pointer or one index. From that index we are only deleting and inserting, and that was top. But in the queue, because we are doing it from two places, front and rear, so those variables were front and rear only. And after that we have implemented all these things. And after that we also discussed one problem, two problems actually, which you guys should practice it later, which is how can we implement queue with the help of stack, and how can we implement stack with the help of queue. These are the two problems which you guys have to solve. Okay. Now let's move into one more subtype of queue, which is called DQ. Okay, let's go back to slides. Everyone here now? Okay, let's see. Let's jump into the DQ part. Yeah. So this is the DQ, which is known as double-ended queue. Okay, and the important feature which this queue has, this queue can be data can be added and removed from both the ends of queue, from the both the ends of queue. I'm not sure any real life example for that. Any real life example? Let's think about. Do you guys think any real life example for this, where we can insert from any place, even from the like? See, the DQ says if we have a queue like this, and if we have like person one, person two, person three, right? One, two, three, and person four in this queue. So DQ says a new person five. If new person five is coming, he could come from here also, and he can be inserted here also. And same goes for deletion. We can delete from here also, and we can delete from here also. So this is what the DQ says, that that if you are using DQ from any of the position, this is front, this is rear. So you can do both operations from any of the place. You can insert also from front, you can delete also from front, you can delete also from rear, you can insert from the rear also. Any real life example, did you guys see that? So Arad is saying book self, book self. So if we are keeping our books in a queue, yeah, I think little bit relatable, but in book self actually we can put it in the middle also. But yeah, little bit relatable. We can keep it in the front also or at the last also. But yeah, I think yeah, it will definitely make sense. Book self is not bad, not bad. Yeah. Corridor, corridor. Okay, how corridor would be fit here? So okay, so if a corridor has two doors, acha. Okay, so if a corridor has two doors, but no, na, it will still like yeah, that's what insertion will happen from rear, right? Ah, okay, okay, I understood what Vishal is saying. Some people can insert from here also, some people can insert from here also, and they can go from their side also. But generally, this not happen, right? In the movie hall also, you have seen that they have some specific exit and some specific entry. So from where you do the entry, you do not exit from there. They have different exits for that. So not much relatable. Understood. I think in colleges also they follow the same thing. From where you are doing the insertion, like if you have conference room, big conference room, generally what they say, from the front side you have to insert, and from the back side you have to go out. I know I have sit in those type of conferences only, from where we have to enter from the front side, and that that's totally true. In some colleges they have one gate also. In one of my college also we have one door. That's not true. That's not only in your college, Arad. So it's not generalized it as a poor or rich. So but yeah, let's come back to our example. Book self could be the good example, by the way, which Arad has given. And yeah, I think if we have one door in one college only, so we can consider that also as a DQ, because we can insert from there, we can go out from there. So that could also be DQ. Any other example anyone is thinking? So that's all actually. That's all about the DQ. Now we have to simply implement it. How can we do all these operations from both of the places? Like from the rear we know the insertion, but from the rear we need to do the deletion now. That is new for us. From front we already do the deletion in queue, but now from the front we have to also insert it. So we have to think about different scenarios. Okay. So now let's jump into our question. Let's jump into our implementation part. Okay. So this is queue, and let's create a new file called dq.js. Okay, let's create a new class dq. Okay, how they are writing it? QUE only, right? Yeah, QUE, not QUUE. Class dq constructor. It will has same three properties. This dot data, which would be our array we are taking, not linked list. This dot front, which is again going to be 0, and this dot rear. But yeah, in programs, guys, in programs, DQ and priority queue, lot of problems they have been solved with the DQ and priority queue, because DQ is providing you one more extra feature, which is from the front you can also delete it. From the front you can also insert it. From the front back you can also delete it. You know about the JavaScript array. JavaScript array actually work as a DQ only. In JavaScript array, you can also insert from the starting position. You can insert, delete from the starting position. Yeah, unzipped. Unzipped is for insertion at the first index, and shift is for the deletion from the first position, and pop and push already there for inserting in the back position, and pop deleting from the back position. That's why JavaScript array play multiple roles actually. It could be queue, it could be DQ also, and it could be stack also. JavaScript array has all three features. Okay, so let's now. So we have created a class. Now let's write the first method. So now there will be four methods, guys. Now there will be four methods. Insert at front, insert at rear, delete at front, delete at rear. Because now from both positions we can do both operations. So now the function would be insert at front. So this is the value which we will insert. Then the other method could be insert at rear. This will also have the value, which is we already done it. Insert at rear, we already know that. Then delete at front, we already know about it. Already done in the queue. And then delete at rear. This one will be new for us. Correct, guys? Okay, so now insertion can be done in rear and front queues. In DQ, not in queue. DQ is a part of queue. Insertion can be done at rear and front in DQ. Okay, Joseph? In queue, if you only said queue, we can only do insertion from the rear side in queue. But in DQ, we can do it from both sides. Yes, it's subset. It's a part of queue. Yeah. This is the example. You can see here, queue, which gives us DQ also. Extended version, you know. You can say queue version 2.0, same like robot 2.0, same like that. You have queue 2.0, which has some extra features, like in the robot movies. Okay, so let's come back to understanding. So insertion at rear, this is easy, right? Insert at rear, same like earlier. Go to the rear. So see, in the DQ, same. If you want to do the insert at here, so like 4 is there, 5 is there. So rail will be 2, front would be 0. Everyone agrees with this? If we have two elements in our queue, 4 and 5, so rear would be at the 2 position and front would be at 0th index. Everyone agree with that? Let me know in the chat. Correct? Now we want to do one more insertion, which is 6. So what will happen? This 6 will be inserted at this position, at the second position, and then we will increase our rear plus plus. Our older scenario, similar older scenario. So that's what we are going to write the code. So this dot data, this dot rear, at this place, do the put that value, and then do the this rear plus plus. Okay, guys. These are the operations for the insertion at rear. Now do the deletion at front. This one already we have covered. Deletion at front. If you want to now delete this one, we'll put null here and increase our front to 1. Correct? Already seen these things. So that's why first I'm implementing those things, which we have already seen. So late index is equal to this dot front. This would be the first element index. Then at that index, keep the null. Keep the null or delete element, something like, I think in JavaScript, keep the null is better. And then do the this dot front plus plus. Right, guys? These are the two operations which we have already seen in queue also. But now there are two new operations, which is front insert at front and delete at rear. Okay, so deleted rear. Yeah, deleted rear. So first see deleted rear because that one is easy. Deleted rear is easy. So let's see that. In the same array. Oh, so same queue. Sorry, same DQ, not queue. In the same DQ, 4 is there, 5 is here, and 6 is here. Correct? This is our DQ. And right now we have not deleted anything. So front is as 0 and rear is at 3. Right? Rear will be at this position. 0, 1, 2, and 3. Correct? So now what we want to do, guys? We want to delete something from the here. We want to delete something from the here. So what we need to do, guys? We need to go for rear minus 1. Wherever is rear is, we need to go for that element. And at that element, put the null. Put the null. At that element, put the null and then subtract our rear. Rear minus minus. Now rear will become 2 and this element will be deleted. And now rear will be pointing out to this new null position. In this position, we will be inserting a new element. That's why I was telling deleting from the back is very easy because we just need to go for the rear minus 1 position and then put the null there and then rear minus minus. And then the new element, whatever new element will come, it will be inserted at this place. Everyone agree with that? Did you guys find the deletion at rear difficult? Deletion at rear difficult, did you guys find? Okay, repeat. Okay, so yeah, so this was the example, right, Joseph? Our rear was at 3. Rear is pointing out to this position. Did you understood this part? Right? Did you understood this part, right? So now what will happen? Now we want to delete this element. Correct? We want to delete. So our scenario is delete from rear. This is our function. So we want to delete this element. So how we will delete? So first reach to the wherever right now rear is pointing out to 3, this index. Correct? So now we have to just do the rear minus 1. So we will be reaching at the second index. So that's what rear minus 1. And this array is data array. So data rear minus n is equal to null. We'll keep the null here in this place. So now this element has been deleted and then rear minus minus. So now rear is again pointing to this position 2. Why rear is pointing to this position? 1 minute, guys. Why rear is pointing to this position? Because the purpose of rear is rear always point out to rear always point out to the position where a element has to insert, where a new element has to insert. So that's why this is now empty place. In this place we will insert. That's why we have moved our rear to -1, which will become 2 here, and then we will be the new element who wants to insert in the queue will come at this place. अब देखो सिमिलर है ना, अगर तुम 2-4 लोग यहाँ खड़े होते, 3-4 4 लोग यहाँ खड़े हैं, ठीक है, अब ये 5th पोजीशन है जहां कोई खड़ा होगा, यहाँ हमारा रेयर होगा और here we have front at the first position. So now we want to delete this one. तो हम कैसे डिलीट करेंगे? हम रेयर के पास गए, we will reach to rear and we will do rear -1, so we will reach here, we will delete this one and now we'll move our rear to this place because now this place is empty. Now this place is empty. So now we'll reduce. Now any new person could come into this place. So that's why we are separating our rear also. Understood, Joseph, now? Understood? So let's implement it. Everyone understood? Some people are saying, no, no, no. Is it about doubt or anything? Like no doubt? Okay, everyone understood, right? Yeah, it was easy. Yeah, it is easy. Front one is little bit thinking. So let's do this one. Deleted rear. This one is easy, I know that. That's why actually I tried it to explain it first. So let's this dot data, this dot rear -1 is equal to null, and then this dot rear minus minus. Let's check the spelling are correct. Yeah, where is there? Where minus 1. Yeah, it will reach to the previous index. And yeah, before that, let's check for empty also, right? If not empty, if it is not empty, then only do this all things, right? Okay, we have not created the is empty method here. So, yeah, is empty. So return this dot rear equal to this dot front. Hey, I have not cross verified this empty method will be same here or not. But let's think about it. Because now we can delete from the back side also, right? But let's think about it, guys. Let's think about it. I have not thought about this, that the empty method will be same like earlier or not. Let's think about it. Okay. So now in starting, both would be at same place. Rear will also be there. Rear will be also 0 and front will also be 0. Okay. Now let's do some in NQ. So first time we did NQ4. Right. So in our queue, 4 has come here. 4 is the first element. And rear become 1. Now rear become 1. Front is still 0. Okay. Now again we did NQ5. Rear will become 2 and front will become 0 still. Okay. And let's look for NQ6. Rear will become 3, front is still 0. So 4, 5 and 6. Right. Okay. So now we'll delete from backside. We'll delete from backside. Right. So this was we are doing from NQ, like insert from back, insert from rear. Now we are doing DQ from rear. Okay. So first time when we will do, so it will become 4 comma 5 only, and rear will be 2. Again rear will be 1 and there will be 0. Yeah, this condition it is matching. Yes. Now our stack is, now our queue is empty and both are 0 0. Okay. Let's look for some other scenarios. 4 5 6. Correct. So first we deleted this one. So now our rear will become 2. Rear will become 2. Front is still 0. Front is still 0. Correct. And now updated queue will look like this. 4 comma 5. Okay. Now we deleted front. Now if we deleted from front side. So element will be 5 and our front would be 1 and rear would be 2. Yeah. Whatever we delete, whenever we are getting front and rear as equal, that would be our empty scenario. I think yes. Wherever we are getting our front and rear pointing at the same index, I think that would be always be empty scenario. What do you guys say? Yeah, condition would be same here, right, guys? So yeah, empty condition is same here. So yeah, here I was using right. So if this dot empty, if not, yeah, if not this dot empty is empty, then go for this. Then do this all these things. Yeah, then do all these things. Otherwise, underflow condition, because already our queue is empty. Why you want to empty it again? So underflow condition. In else, we can simply return or throw error, throw new error, underflow condition. Underflow scenario. Okay. Okay, so now guys, let's come into the bigger one. I think the same condition will here also, guys. Let me write it. If not is empty, wherever we are doing the delete, same thing will happen. Yeah. Let's do the proper indexing. Okay, now comes the first scenario. insert at front. So guys, insert at front has three scenarios. Let me show you. Insert at front has three scenarios. You guys can guess what are the three scenarios? What could be the three scenarios while we are trying to insert from front? Anyone? Just think about it. Okay, first empty. That's right. If our queue is empty, first scenario. If queue is empty, totally right. What about the other scenario? This is the first scenario. What about other scenario? If front is occupied. No, no, no. If front is occupied, it could be in two ways. Think about it. Your answer is correct, Vishal. But just little bit more. If front is occupied, it could be occupied in two ways. But that's right, front will be occupied, but it will be occupied in two ways. Likit is saying full. What does it mean? If front is full, that's what you mean? Or RQ is empty, RQ is full. RQ is full, that's fine. If RQ is full and if we are trying to insert something, it will be overflow. Okay, guys, so let's think about it. I think, yeah, first answer is totally correct. Second one is also correct, which Vishal has given. If front is occupied, but front could be occupied in two ways. Front could be occupied in two ways. And the first way is if we have not deleted anything. If we have not deleted anything in the queue. So front would be at zero position always. Right? If we at the zero position, if we at if we have not deleted anything, here rear would be at the 1, 2, 3, 4, 5. Ah, 5. 5, yeah. So rear would be at a 5. So this is the first situation where front is 0. We have not deleted anything. So we have to simply, okay, 1 minute. So this is the first scenario. And second scenario is, guys, if front has some greater than 0 value. If front has greater than 0 value, when will it happen? So if in the same array, if we delete 4, so the above DQ will look like this: 5, 6, 7, 8, and null. Right? And now front would be 1 and rear will be 5. These are the two scenarios, guys. Because in this scenario, you just need to subtract your front to back, and you have to insert in this position. When the front is greater than 0, you just need to subtract your front -1 and you have to insert at that element. So for this scenario, code will be like this: this dot data, this dot front -1, and the value, and then this dot front minus. Because these are some empty spaces already there in the queue. So first we will fill them, right? There are already some empty spaces. So first we will fill them. So that's why this is the second scenario. Okay, understood everyone? When the front is greater than 0, when we add last number. No problem, Marad. That's right. Could we always keep 0 as a null in case we get an entry from front? Could we always keep 0 as null in case we get an entry from front? So even if we got one entry and we filled our 0 as a with that entry, what will happen if we got again the next entry? what will happen if we again got the same and again got the different entry, right? At that time, our front will be 0 first time. Then you did 2, 3 operations. Again, your front become 3. Yeah, that could be the problem. That's why we need to check for 2 scenarios. When our front is 0, it means nothing. No, we do not have any space in our. We do not have any prior space in this thing. It means like there are 5 spot. It means like it's like real example, guys. It's like there are 5 spots. 1, 2, 3, 4, 5, right? And if already first person is here, so now if you want to insert somebody here, you can't. You can't insert him here. So for that, what you need to do, you have to shift all of the persons to one right. So this 5th person will come at the 6th position now. This 5th, like if I write the number here, 1, 2, 3, 4, 5. So this 5th person will come at now 6th position. This 4th person will come at the 5th position. अरे भाई इतने बर्ड्स ज़्यादा सायरन ना. The second person will come at the at this position, right? And this person has to come to first position. Something I missed it. 1, 2, 3, 4, 5. Yeah, 6, 5. 4 I missed. This has to come at the 4th position. This has to come at the 3rd position. This has to come at the 2nd position. Now you can insert the new element here at the 1st position. Okay, so this is the scenario where front is 0. But if your front is 2, it means there are 2 already empty spots available. There are already 2 empty spots available. And if our front is 2 and our rear is 4, it means there is already one person standing and 4 would be here. No. Yeah, 0, 1, 2, 3. Yeah, 4 would be here. No, 4 would not be here. 4 be here. Yeah. If rear is 4, it means it will be here. The 4th position. 0, 1, 2, 3, 4. Yeah, 4 would be here. Rear would be here. So now you can see there are 2 positions already available. So we do not need to shift anyone. So this is the second scenario. So at that time, what we will do? Our front will be here, right? Front will be at the 2 position. So what we will do is then we'll shift our front to here, front 1, and then we'll insert at this position, new element. Again, if anything is coming at the front, we'll again subtract it to here and we'll come in here. And then if again new one is coming, we'll go into this scenario where front is 0. Understood, everyone? We have seen all 3 scenarios. In first scenarios, when there is nothing in the queue. Sure. So first scenario was when there is nothing in the queue. Our queue was empty. So we can repeat it. We can insert it in any position. Okay. Now let's talk about the 2 scenarios which front has. So now front has 2 scenarios. Similar like this one. If we have the first scenario when front is at 0 position, it means nothing has been deleted. And these are 5 spots. Okay, 0, 1, 2, 3, and 4. And somebody wants to insert it here, but there is no space. So we need to shift everyone to their right. And once we'll do that, we'll simply do this. Now this 0 will come at the 1 position. This 1 will come at 2nd position. This 2 will come at the 3rd position. This 3rd will come at the 4th position, and this 4 will come at the 5th position. Now this here we have one empty space. Every time whenever we got the front is equal to 0, we always have to shift. We always have to do all these things if our front is 0. But the second scenario, if front is not 0, if front is 1 or 2, it means we have already two empty spaces in our spots. We already have two empty spots, and these are those two empty spots. You know that, right? Whenever we are deleting, whenever we are deleting at front, we are keeping null on those indexes, and then we are moving our front plus plus. So it means all those indexes where we are keeping the null, those indexes are empty. And when those are indexes are empty, so what we will do? We will first insert at that index. So 2 minus 1, we'll just subtract our front to this place. And then next element is coming for insertion at front, we'll insert it this place. Now front will become 0, and it again, if new element is coming, it will follow this strategy. It will follow the first strategy, because now our front becomes 0. Just visualize it. 5 people are standing in 5 spot. Okay. Or if your queue is now like your front is at 0, right? So now if somebody wants to insert at that first position, what do you need to do? You have to shift everyone, right? तुम्हें एक एक करके पीछे जाना पड़ेगा. एक लाइन में पीछे हो जाओगे, right? So that's what the first scenario. But the second scenario, if already two spots are empty, if already two spots are empty in front of you, so then you do not need to shift back. You can, whoever is coming next, whoever is coming a new person, he can enter into the second position. Then whoever is coming next, he has to come into the first position. Now if third person is coming, again you have to shift it now, because now your front becomes 0. Understood, everyone? You guys want me to repeat it? I think the second scenario lead to priority queue. No. In priority queue, all the element we insert or delete, it happened based on priority. Could not understand the second one. Okay, so second one is when front is greater than 0. That one, right? Yeah. So okay. It's looking like difficult for you to visualize it. Okay. Let's see that. I'm thinking if we can take any better example. Okay. Let's take one array. 4, 5, 6, 7, 8. Okay. This is our queue, right? Our front is right now at 0, and our rear is at 0, 1, 2, 3, 4, 5. This one agree? Everyone agrees with that? Let me know in the chat. Everyone agrees with this? Everyone agrees with that? Yeah. Okay. Now do the deletion from front. Do the deletion from front. So DQ from front. So what is the code you have written? You go to the front position, put the null there. And increase your front to 1. Correct? That's what the code you have written. Go to the front position, put the null there, and then front plus plus. Everyone agrees with that now? Everyone agrees with that? Everyone okay with that, right? Let's do one more deletion from front. Now our front is at 1 position. It means we need to delete 5. So DQ from front. So it will look like null, 6, 7, 8. Front is at 2. And rear is at 5. Everyone agrees with this also? Arad, you understood, right? Okay. So now guys, we want to insert from front. Insert from front. And as you can see, there are already 2 empty spaces. These are empty spaces, right? I told you, right? These nulls are nothing. These are empty spaces. Everyone agrees with me? These nulls are empty spaces. Okay. So now, whenever a new number is coming, like 9, if you want to insert a 9, so this number has to come at this place, because these are empty spaces are here, right? So this number has to come at this place. This is the first empty space. So what we'll do, we'll look for our front value, wherever our front is. So our front is right now at this place. So we will do front minus 1. So as we do front minus 1, we'll get 1. It means this position. And in this position, we will insert it. This dot data, this dot front minus 1 is equal to value or 9. And then we'll do this dot front minus minus. इससे क्या होगा? Now our front is coming at 1. And rear is still at 5. And how our array look like? Our array will look like this. Null, 9, 6, 7, 8. It will look like this. Now again, one insertion is coming from front, and which is 10. So again, now our front is at 1 at this position. Again, we'll do 1 minus 1, 0. In this place, we will insert it. 10, 9, 6, 7, 8. And again, we'll do front minus minus. Now again, front has come at 0. And rear is still at 5. Correct? From there only we started, right? 0, 5. Now we are coming back to same scenario. So that's what. Now, if again something is coming from insert from front and 11, now you do not have any choice. You need to change the indexes. Now 11 will go there, 10 will be here, 9 will be here, 6 will be here, 7 will be here, 8 will be here. Now front will be here. We have to shift all the element to the right of there. So front will again at the 0. And rear, guys, you know, rear will change. Rear will be 6 now. You can see 0, 1, 2, 3, 4, 5. And rear will be at 6 position. Because we have shifted out one element. So in this scenario, rear will also be, when our front is 0, our rear will also be changed. Understood? We need to shift it. Yes, we need to shift it. In the scenario when front is 0. Everyone understood now? Joseph, Arad, Suraj. Clear, right? So let's implement it. Let's implement it. So let's implement from the first scenario where inserted front. So if this dot is empty, if our queue is empty, we just simply need to call insert at rear. This dot insert at rear and pass the value. Correct? We have to insert it from back. What happened? Okay, curly braces is not there. Yeah. Everyone agree with that? If the queue is empty, we could go from the back. Okay. Now let's go for second scenario. Else if this dot front is greater than 0. The second scenario, this one, which we talked about, this one, if our front is greater than 0, here what we need to do, this dot data, this dot front minus 1 is equal to value. At that position, keep it. And then do this dot front minus minus. Everyone understood this part also? Where it's greater than 0, right? Let's look for the next one, which is now there is only one condition, which is else. It means it's not empty, it's not greater than 0. It means now it's equal to 0. For this, we need to put a loop here. For that, let's think about it. Let's put a loop here. And our loop will be on whole array. Yeah, so this dot data on whole array. Yeah. This dot data I less than this dot data dot length and I plus plus. Correct. And what we need to do, this dot data I plus 1 equal to this dot data I. Correct. So one position पे 0 plus 1 पे 0th position का item. and 0 plus 2 per first position ka item. This will work like this, right? If we have 10, 9, 6, 7, 8, this is our original array. And if we are doing array I plus 1 equal to array I, oh, by the way, we will be lost. We will be losing this data. We will be losing this data. I think this is not good. This is not good. Did you understood the problem, guys? Did you understood the problem while doing the traversing? Yeah. Yes. Arad has given correct answer. We should do from last. So if we will do from last, from here, so what we need to do, array of I is equal to array of I minus 1. Right? Array of I is equal to array of I minus 1. Yes. This will work. Let me show you how. Totally right. So 0, 1, 2, 3, 4, and 5, right? So we are starting our loop from array dot length. So which is 5. We are starting our loop from fifth index. So now we'll do array of fifth is equal to array of 4. Correct? So at this fifth position, 0, 1, 2, 3, 4. At this fifth position, 8 will be there. Right? Now we can delete this fourth position. Now at the second iteration, when 5 will become 4. So array 4 is equal to array 3. So now 7 will be at this position. Same goes for 6. Same goes for 9. Same goes for 10. And now we have the 0 index for insertion a new element, which is 11. Got it, guys? Got it, guys? Yeah, we'll do that, and at the end, we'll definitely increment the array. So this was wrong. So let's start from backside. This dot data dot length I greater than equal to 0. Oh, no. We do not need to go for 0, right? Yeah, I greater than 0. We do not need to go for 0. We are okay with the 1. Once we reach the 1 position, so that time would be array 1 is equal to array 0. So now whatever is 0 will be put it into 10. So that's why greater than equal to 0, I minus minus. And here you do this data dot I, this data dot data I minus 1. Okay. And once this loop is done, at first at the 0 position, keep the new element. And then do the this dot rear plus plus. Okay. This dot rear plus plus. Okay, everyone agrees with that? Everyone agrees with that? Right? So let's test it also. Let's call our functions. We have not done the print. We have not done the print, right? I less than this dot data dot length I plus plus if this dot data I console dot log dq elements this dot data I. Okay, let's do the, let's call it let dq is equal to new dq. So we have initializer dq class. Let's do some insertion at front or rear, anything you want to do. If you will do the inserted in front, this will also do the inserted front. Let's do the 4. Again, do the dq dot inserted rear. So now after let's 5 dq dot insert at rear again, which is 3. Okay. Now do insert at front, which would be 1 or 8. Can do dq dot insert at front, which would be 9. Now let's print it out. DQ dot print. So we have done only insertion. You guys tell me in the chat what will be the output for this scenario. We have done insert at front 4, insert at rear 5, insert at rear 3, then we did insert at front 8, insert at front 9. Quickly, everyone please write in the chat how the queue will look like. Line number 10 we inserted front, right? Line number 10. Inserted rear. It's empty, right? It's empty. So always when the queue is empty, we start from back side. Okay, you first tell me the answer for this scenario. Everyone, insert at front. Oh, I've taken delete. Hey, sorry guys, I have not taken delete. 1 minute. I have to take the insert at rear. I was just inserting it. Insert at rear, insert at rear. Yeah, insert at front, insert at front. Please tell me the answer quickly, guys. Nobody is answering. What happened, guys? Visualizing. So Diviganta has given first answer 98453. What about others? Vishal is giving 89453. Yeah, just see it clearly. No hurry. Insert at front, insert at rear, insert at rear, insert at front, insert at front. Yes, so 98453 would be the answer. Totally right. Vishal has given correct wrong answer by the way, but he has realized it, I think. pq.js. Let's see. 98453. Correct, guys. Now let's do some deletion. Now first delete it from rear side. Delete at rear. Let's do again. Delete. Or now let's do dq front. Delete at front. Now you guys tell me how will this look like? Now you guys tell me what will be the output after deleting at rear, after deleting at front. Tell me quickly in the chat. After deleting at rear, after deleting at front. Yes. Yes. 845. Let's see that. Yes. 845. Okay. So that's all, guys, about this also. Let me delete the older one. This one was the older one, or yeah, this one was the older one, right? Yeah, DQ was the older one. Let me first commit the changes. Git st, git add, git commit -m, queues, git push. Yeah. So now it will be available in there also. So I think that's all from this slide. We don't have anything else in this slide, but there was one question actually I had for you guys. I think that was in the lesson plan. That was how can we reverse these elements? How can we reverse this element in the queue? I know you guys have already know about the stack reversion. Can we use the same strategy here for reversing element in queue also with NQ and DQ? Same strategy which we use for the stack in the stack for doing the reversion, for doing the reverse. Can we do the similar thing here? You guys tell me in the chat. How we will do the reverse in reverse? So if we have one element like this in the queue, this is our queue. I always create a queue like this. 5, 1, 2, 4. If you want to reverse it, and then we want to do it like this, 4, 2, 1, 5. Now I'm talking about Q, not DQ. Now I'm talking about Q. Now I'm talking about Q, guys. Yes. So yes, Joseph has answered correctly. We can use the recursion, right? So we can simply first do the DQ as we were doing the popping. We'll save it into one auxiliary space, and we will save it. We will save it, and then once we at the end we will start inserting them. Start inserting the last element which we got in the popped. What do you guys say? Will it work? Let's think about. Let's think about. Will it work or not? So in the first recursion, our temp will have 5, right? Second recursion, our temp will have 1. In third recursion, our temp will have 2. In fourth recursion, our temp will have 4. Yeah. Then we are coming back into the next line, and then we will start enqueuing them. So we will do NQ4, NQ2, NQ1, NQ5. Yes, this will work, guys. So now you will get this result 4215. So try it in your time. Okay, as we try the reverse for stack, you can use the same strategy here as well. Okay, guys, did you understood? We can do this with recursion, the reverse part of Q. Understood, everyone? If you have understood the stack one, then I think this is not difficult. It's just the operation. You just change the name of operation. From pop, you put it DQ. From push, you put it NQ. Everything is same. Okay. So I think that's all from today's class, guys. I know this class was not that much heavy. Or we can swap front and rear element too. Front and rear element, if we will swap it. If you're talking in the array terms, if you are considering Q as an array, then you are making mistake here, Avarat. Because it looks like you are considering a Q as an array. That's why you're using 2 pointers, and you can simply swap it. But Q is a different data structure which uses array as implementation. But in the case of linked list, then it will be difficult, right? If somebody is internally has implemented Q with linked list, will your 2-pointer approach work there? How will you reach to 2 pointers? Just think about it. Yeah. Think about it. Yeah. So okay, yeah, guys, that's all about. I think. See, this was very what we say, not the heavy content you guys have taken today. I think now, after once we will jump into the Q's question, I think then we will be seeing some heavy questions which are going to ask. But before that, I want you guys to practice it from the stack till whatever we discussed. Very important, very important. Practice it everything. And then we will be looking into our, I think next class will be going to be for questions on Qs, I believe. Okay, and I'm going to keep everything in the Q branch. Yes, and these things are very interesting also, right? Once we started with linked list, did you guys like, are you guys feeling boring? Before that, I think it was little bit here and there when we were looking for sorting, and when we were looking on the sorting part, it was looking like little bit here and there. But I remember the binary search was also very interesting when we were doing the questions, and then we jump into the stack. Stack was also very interesting. From linked list also it was very interesting. And now Qs is also going to be very interesting. There will be a lot of nice questions in Qs also. Okay, guys. So let's wrap it here and enjoy the weekend. And please do the practice also. Yeah, sorting is concept wise. Actually, we need to learn those things, insert, queue, and those things. But yes, we should know that. Sometimes they ask it in the interviews, merge sort and all those things. Merge and quick sort. A lot of questions I've seen merge from the merge and quick sort. And even they ask the time complexity for that. In the sorting, they ask a lot of they most of the time ask complexity. In sorting, I have seen. Okay. So yeah, so that's all guys from today. Hope you enjoyed your the weekends and also do the practice. And if you guys have any queries, any doubts, you know where to post it. You just go into the LinkedIn, post in your group. I will answer it there only. Okay. No enjoy, Suraj. Why? What happened? So see, put song, put song, and do the code repetition. Hey, once you will get the good like top one company, then all of the hard work, all the work which you are doing, that all will feel like yes, we have done the correct thing. It all will feel like yes, we have done the right thing. When you will reach to the that much big organization, you will get a nice bonus and whatever the meaning of enjoy for you is, you can do them. You can easily do that after that. So that's what the motivation is to reach to that organization where we can easily crack the interview for everyone. Okay, guys. So that's all. So today actually I woke up a little early to just cover some of the programming question. So let's see how things goes. Okay, guys. Bye bye. Have a nice day. We'll meet and talk on Monday. Okay. Bye bye.